Alrighty, so we're going to continue on. This is section 7.3. We're on part 3 now. So we've gone over, I've given you a chart of what trig substitutions to do when, and now we're just applying that. So we have example 3. So we want to find the integral. So this is an indefinite integral. We have 1 over x squared times the square root of x squared plus 4. And this one's different from the last couple ones we did. So the last ones we did were sign substitutions. This one's going to be different. So we're going to have the integral, dropping my dx's, 1 over x squared square root of x squared plus 4. We're going to do trig substitution because we have that square root here, nothing to do with anything else. So if you look at your chart, this is going to be a tan substitution. We want that when that shouldn't be an a there, that should be an x. We want that, when we square x, we're going to get a 4 in front of the tan. So this is going to be x is equal to 2 tan theta. Dx then is going to be 2 secant squared theta d theta. I'm going to go ahead and solve this one for theta. Get theta is equal to the arctan x over 2. We're going to need that later, just not now. I'm just getting it ready. Okay, so let's put all of this together. So this integral then is the integral of 1 over x squared is 4 tan squared theta times the square root of 4 tan squared theta plus 4. Dx is 2 secant squared theta d theta. All right, so just keep going. The integral 1 over 4 tan squared theta. Pull the 4 out from the radical. You're going to get square root of 4, which is 2, times the square root of tan squared theta plus 1. 2 secant squared theta d theta. Here we're going to need the fact that tan squared theta plus 1 is equal to secant squared theta. And we'll just keep going. This is the integral of 1 over 8 tan squared theta. So 4 times 2 down there. Square root of tan squared. So tan squared plus 1 is secant squared, square root. Just going to get a secant down there. And I have a 2 secant squared theta d theta. Going to have 1 power of secant cancel there. So I'm going to be left with the integral 1 over 8 tan squared theta. And then 2 secant theta d theta. Just keep simplifying. 2 over 8 is a 4th. Pull that out of the integral. I have secant theta over tan squared theta d theta. So if you look at this, it's not, any of the trig forms that we had from section 7.1. It's not a u substitution. So let's try and put things in terms of sine and cosine. That's kind of our last resort. So secant is 1 over cosine. 1 over tan squared is going to be cosine squared over sine squared. We'll keep going. 1 power of cosine cancels. I have cosine theta over sine squared theta d theta. This is a u substitution integral. You let u equal sine theta. Du will be cosine theta d theta. So this is 1/4 the integral. I have a cosine theta d theta here. So this is going to be 1 over u squared du. This is negative 1 over 4 times 1 over u plus a constant. And now I'm going to plug back in for u. U is sine theta. Making sure that it's what I have with my work right now. Yep. Plus a constant. And now comes the tricky part. I don't want this in terms of theta. So you'll remember I solved for theta up top. I got theta as the arctan of x over 2. I'm going to draw my triangle. We're going to call this the arctan x over 2. Because I want the tangent of the arctan of x over 2, I want arctan of x over 2. This has to be equal to x over 2. So if I take the tangent of this angle, tangent is opposite over adjacent, so that'll make it x over 2. And that makes this side the square root of x squared plus 4 by the Pythagorean theorem. So now what I want, so maybe I should have done this first, and I apologize. I know where I'm going with this. So going back to our answer, I had this minus 1/4, 1 over sine theta plus c. If I plug back in for theta, this is minus 1 over 4 sine of the arctan x over 2, because theta is arctan of x over 2 plus a constant. So my answer I want to write in terms of, so the answer to this integral, the integral 1 over x squared square root of x squared plus 4 dx, it's going to be, I need to change this back into, I need to figure out what the sine of the arctan is. So if arctan is given, so if I have this triangle with the arctan, the sine of this angle is going to be, so that I get sine arctan x over 2. So if I look at the sine of this angle, it's opposite over the hypotenuse. Then I just plug that in. I'm going to get negative 1/4. I'm plugging it in again in this big highlighted spot that I can't really highlight anymore. I guess I can erase it and highlight it. So this big, so I'm just using this. So I get minus 1/4. Sine of the arctan, I use the triangle to find. This is 1 over x over the square root of x squared plus 4 plus a constant. This simplifies just a little more. This is minus 1/4. I can flip that up top. X squared plus 4 divided by x plus a constant. And that's my final answer. It's in terms of x now. So again, you have to do a couple of these yourself. They are difficult, but when you do them, it's it's the same thing over and over. It's just a method, so it becomes easier. So I'm going to move on to example 4. So we want to find the integral. So evaluate the integral of x over the square root of x squared plus 4 dx. So I don't know if any of you guys, pause me and try and solve these before I go through and solve them and compare. Some of you guys catch, a couple of the mistakes I've made. So I'm hoping that, you're at least working along. But, if you look at this one, you might be tempted to jump straight into a trig substitution. And it might work. I don't know if it will. It could. It might work. But the point here is there's an easier way of doing this integral, and we always need to be looking out for that. This is a u substitution integral. Because, the derivative of x squared plus 4 is 2x, and that x appears in the numerator here. This u substitution looks to be the best way to go. So I get dx is 1 over 2x du. So I use u equals x squared plus 4, du is 2x dx, which gives me dx is 1 over 2x du. And however you do these these u substitutions is fine. So this x stays the same up top. The square root of x squared plus 4 is now square root of u. Dx is 1 over 2x du. X is canceled just like I want. So this is 1/2 the integral of u to the minus 1/2 du. 1/2 u to the 1/2 divided by 1/2 plus a constant. So u to the 1/2, it's going to be the square root of, so u is x squared plus 4 divided by 1/2 plus a constant. So the 1/2, you can simplify that, those cancel, you get the square root of x squared plus 4 plus a constant. So you should always be on the lookout, you know, on your exams. We're not always gonna be like, use this method to solve the integral. The hard part of integral calculus is you have to sit there and figure out what you're going to do. It might not always be right the first time, and that's fine. You just have to be on the lookout for when things start going wrong. And if they start going wrong, you have to jump ship and try another method. So you should always, you know, look for the simplest method, but if that doesn't work, try something else and think through it first. So I'm going to stop this video here. We'll continue with a couple more examples.